Over half of Canadians are either overweight or obese, which puts them at an increased risk of many serious diseases, including diabetes, stroke, heart attack, and cancer. Therefore, we need to find a way to reduce the prevalence of obesity. Now, many people believe that our weight is primarily determined by how much we eat and exercise, but that isn't entirely true. As an example, let's say that you weigh 150 pounds, and you go out to a restaurant and you eat way too much food. It happens to the best of us. But you likely won't gain any weight from this supper, and that's because our brains work very hard to maintain our weight at a certain value, which is called our set point. Our brains do this by monitoring how much we eat and adjusting our metabolism as necessary. But this just raises more questions. If our brain is so good at maintaining our weight, why is the rate of obesity so high? Now, the answer is fairly discouraging, to say the least. What happens is when we eat palatable high-fat foods like pizza, burgers, all the good stuff, the body weight set point actually shifts up and the brain maintains the higher weight. So back to our example, you're 150 pounds, you overeat high-fat food for a long period of time. What happens is your brain will stop defending the 150-pound set point and will start defending the 200-pound set point. So in fact, your brain does this so well that it makes diet and exercise largely ineffective to achieve stable long-term weight loss. And since dieting and exercise is really our only treatment against obesity, we need to find new weight loss strategies. The approach in my research is to see what changes are occurring in the brain to cause a shift in set point. Now, there could be many neurons that are responsible for this. Those are brain cells. But I'm focusing on a particular cell type called MCH neurons. I'm interested in MCH neurons because when they're activated, they increase food intake, they decrease your metabolism, and they promote weight gain. In fact, they contribute highly to our set point. So I fed animals a low-fat diet and a high-fat diet, and this is a sample of my data. What I found is that MCH neurons are actually more active in animals fed a high-fat diet. So here, each of these upward deflections, these spikes, represents the activity of MCH neurons. In the high-fat condition, there are more spikes, and also the baseline is shifted up to promote more activity. This would cause weight gain and also might reflect an increase in the set point. So, to conclude, current weight loss strategies are ineffective to combat the obesity epidemic, but novel treatments aimed at the changes in the brain produced by high-fat diet, like the increase in MCH neuron activity, could be a potential treatment for long-term weight loss. Thank you.